I would cover this thing called expansions. Well, that's what I want to talk about now. What I'm about to show you is not specific to the echo command, but we'll be using the echo command to help illustrate how these expansions work. So when I say expansion, what I mean is that there are special characters and special syntax that we can use with various commands that the shell will interpret and expand into some other value. And probably the simplest example is actually something we've seen before, the tilde. Tilde expansion, if I just echo the character tilde. Tilde has a special meaning. I'll zoom in a little bit. As we've talked about, it is a shortcut that refers to our home, or my current user's home directory. So here, tilde is /user/cold steel. Now when we echo it, what we're actually doing is asking the shell, print out tilde, but it's not the character tilde, right? If it's in quotes, then we get the tilde printed out. What it's doing instead is it's expanding that character. It has a special meaning. Before it even runs the echo command, it's going to replace that or expand it to be this, and that's what it echoes out. So when we do things like cd tilde, again, the shell steps in and says, oh, I know that, let me expand that, and it turns it into /user/cold steel, and that is where we cd to. So at cd tilde, it's the same end result. Alright, so there's other types of expansion though, including $environment variable expansions. So in our shell, there's a bunch of environment variables available. Some of the more common ones are things like $path in all caps. If I echo that, you'll see that it's been replaced with a very long, maybe much longer actually than this. It's not too bad. If I run it over here on Ubuntu, I think I have quite a long path here. Nah, not too bad either. So it takes this and it turns it into, or it expands it to the value of that variable. Now if you don't know much about environment variables, don't worry about it, but here's one more example. User, that's an environment variable for the current username. Okay, now a more useful thing is path name expansion. So path name expansion allows me to use special syntax, special characters to match different path names. So we've actually seen this before, we just haven't called it path name expansion. I'm in a directory right now, well I'm in my home directory, aren't I? So there's a whole bunch of stuff here, different files and folders. Why don't I do this over on Ubuntu because I have some more files to work with. Okay, so when I type echo, I'm just going to use echo again because it's an easy way to see what the shell is doing for us. So it's just going to print back the expanded version of the star character. So if I wrap the star character in quotes, that's what we actually get echoed back. But if I don't have those quotes and I simply echo star, what I see is a list of every path name in this current folder. So every folder, every file name, like Pokemon.txt, Word.txt, and then different folders like cleanup and copies. I'm just matching everything. So the star means every path here. But I can narrow it down. And I can say star.txt, and we've seen this sort of thing before. Again, this is going to then be replaced with matching paths. So this was replaced with all of that. Now if I do star.txt, it's only going to match something that starts with anything, but ends in exactly .txt. Okay, and so here we are, we see our matches that end with txt. Now echoing them may not be that useful, but I can do things like ls-l star.txt. I want to print out long listing information about all text files in here, and there we go. I only see .txt files and all their information. So we also have another character we can use to match path names, which is the question mark. A question mark will match any single character. So this would match any 3 characters in a row. This would match any 4 characters in a row. So let me show you an example. If I echo, and I'll do anything, so the star matches anything, and then a dot, and then any 2 characters. So this looks weird, but it's saying anything that must then end with a dot, and then exactly 2 characters. I don't care what those characters are, but 2 characters. And we don't really match anything, do we? In this folder, I guess we don't have any. All right, well, let's try 3 characters. And now we're just matching all our .txt files and .zip files. It's not that exciting, but just as an example, if I were to touch app.py and app.js and main.js, all right, and then I ran our original version here, which is anything with a dot and then exactly 2 characters. Now we're matching those .js and .py extensions. So I'm echoing them. Again, that's not what we would normally do. We might do something like ls, or you can do rm. If I want to remove all of those files, this is kind of very dangerous. I don't know if I would recommend this, but just as an example, I could remove those files that have 2 character extensions. That would be a very common thing to want to do, just all 2 character extensions, but I can. rm star dot question mark. So remove all files in here that end with 2 character extensions, and I have it set up again automatically to ask me, prompt me if I want to. So I will say files. Remember using git, using the git diff command, you'll actually see what it relies on behind the scenes to generate a diff. But first, let's look at two files, or at least one file, that is slightly different than another. So I have this nice flavor name flavors file. I'm going to copy. So name flavors. I'm going to make another file called name flavors 2.txt somewhere original. Alright, so now we have two of them. And if I compare the two with diff at the moment, they are identical. There's no difference. So let's change something in name flavors 2. Let's echo another thing in there. How about there's another flavor. Let's just do mint again. And I'll append. Not for the sake of reference. 2. I want to append name flavors 2.txt. Okay, so now that exists at the end of that file. Just that one extra bit. So if I rerun my diff between those two files, this is what it tells me. 124A25 mint. We could spend a lot of time talking about how this works, but the recent change what it's telling us is that on the first file, line 24, on the second file, line 25 is added. So if we change the direction, if we instead compare fave flavors 2 to fave flavors just on its own, now the output says line 25 on the first file. Line 24 on the second file was, I don't know, the D stands for deleted, I believe. So, appended, added, deleted. We can have multiple diffs too in a file. Just if I quickly change something in, how about in fave flavors 2, so let's open that up. I'm going to change something on line 3. I'm going to do strawberry and cream, alright? I'm going to save that file and close it. Now, if I do my diff between fave flavors and fave flavors 2, we see we get two different things that were changed. Line 3 of both files, it was changed from strawberry to strawberry and cream. And then line 24 of the first file, line 25 of the second file, added mint. Anyway, this is one way of using diff, but what's probably more common, more useful, is to see both files side by side with -y. So that's one option for passing -y, although in this case, way zoomed in, it's kind of disastrous, isn't it, on this screen size, because I've tried to make things readable. But if my font were quite small, you'd see it side by side. And then lastly, we have the -u option, which is what Git uses behind the scenes to display its own diffs. And this just gives us a different output. If we look at man diff again, and we go down to -u, output the num line to the unified context. So it gives us some context around each change. So let's do that again. Instead of -y, -u. And what we see here are the files that we're comparing, and then context. So saying from line 1 to 6, we can see what was added or removed. And then same thing here, we can see what was added. So this is maybe familiar if you use Git, and that's the basics of the diff command. Next up, we'll talk about the find command. So find, of course, find files or folders matching some file pattern. There's quite a bit to it, and we could have a 20-minute video at least devoted just to the find command. So I'm going to just try and hit the highlights here. The first thing you should know is that we can find files and folders by a bunch of different criteria. We can find based off of, let's open up the man page, based off of the name of the file, the modification time, the file size, the type, if it's a file or a directory or a symlink. There are probably many others that I'm forgetting at the moment. And I'm just scrolling through the man page here. It's quite long, as you can see. So again, we're just going to hit the some of the highlights here. Okay, so the first thing is if we want to find files or directories, we need to provide a location to look inside of it. So find inside of, in this case, dots, the current folder, or find in the desktop, or find in my animals folder. And then we provide some sort of criteria, something to searching So if I do a find dot, it's nothing, it's just find dot. It is going to find every single file nested somewhere inside my desktop. So there's a lot of stuff going on. If I scroll, you can see that they're nested. They're not actually on the desktop. They're nested multiple levels deep. We didn't specify any way of narrowing what we're looking for. Now let's find everything that has in its name, and then inside of quotes. Let's search for anything that has about the number 7 anywhere on my desktop or any folders nested in the desktop or folders nested in those folders and so on. Really? No. Why didn't we find anything? Aren't there basically one file that has a 7 in its name? And the answer is that it's looking for an exact match. A file that has, and is called 7. I made a file called 7 right here. If I reran it, it would work. We found that file. But what I want to do is find any file on my desktop or nested somewhere on the desktop that has the number 7 in it. So this is where the special wildcard characters of a star, in our case, will come in. A star is just going to refer to anything, and then a 7, and then anything else, optionally before or after. So if I do this, we now get a bunch of matches, a lot of Pokemon that I have for a different video I made, that have a 7 in their name somewhere. But I'm sure there's some non-Pokemon. Here we go. Morning day 27, nested very deep inside of this folder. Or here's file 257. So we found files that contain 7 in their name. So if I wanted to find all files of a particular type, all Python files .py, I would put a star, which again means anything followed by .py. And looks like there's just one. Let's try a .js. We've got a couple of JS files nested in my desktop. Now remember, dot is where I'm searching inside, and that's just my current location. But I could instead say, I want you to search only within the stuff folder. If I can spell it correctly. It's not going to find anything, but maybe I'll find TXT files. And there we go. Only find TXT files inside of this stuff. So we can also find by type. I can find directories or files or ziplets. So why don't I do a find on my desktop once again, and all that I want are any entities, anything that it finds is the folder directory. Now I forgot to specify where to search. We'll search in our current directory, and I get a list. These are all directories. There's a lot here, but no files. You notice none of the actual files are present. They're .txt or .js or whatever. It's just the directories. If I did type F, I only get the files. As you can see here, these are all, and of course they don't have extensions, so you can't tell, but you have to trust me. They are all files for each Pokemon in this case, or wherever you're seeing them. They're all files. There are no directories that have been found. Now there's directories referenced in the path to each file, but that's not the same thing as the actual directories being returned as a result here. So we can combine them too. Maybe I want to find directories only, so I'm going to use -type is D, and name as, I don't know, how about an uppercase E? We'll see if we find anything that contains an uppercase E, and we do. So only directories somewhere on the desktop where in their name they have an uppercase E. So here we go, uppercase E, these are all directories. Now, I can also do a case-insensitive version. If I do I name or insensitive, I'm not going to find anything that has an E and doesn't actually matter if it's uppercase or lowercase. So we see things like right there, there's an E in that directory's name. There's an uppercase E and a lowercase E. Okay. We can also do fancy logical things like use the OR operator, so -OR. So let's give it a shot. Let's find anything that has its name, so in our current location, -name, starts with the letter E. So essentially, E, and then followed by anything. Now, remember, So put a star there, that means anything can come before the E. What I want is it must begin with the letter, in this case, uppercase E. So we get a bunch of things called there's some others, Edgar, Ethel, Elvis, instead of chicken directory. Now, if I also wanted to say, or name starts with, how about F, star. And now I have fall, Bungus, as well as Espion and, files and directories that start with F or E, uppercase E, because I didn't do I did. So that's just a taste of the or operator, but also the not operator. We can do things like search by file size, bytes, megabytes, greater than something. So for example, find files that are larger than 100 kilobytes, but smaller than 1 megabyte. So find where the type is file F and size is plus 100K, greater than 100K, and size is minus 1M, 1 megabyte. So let's try an example. Let's do find where type is file and size is greater than 100 kilobytes. And there we are. We get a list of files that are greater than 100 kilobytes. If I let that size off, way more files. We can also use things like time. So if we want to find files that are located more than 3 kilobytes, dash M time, modify time, plus 3. And then the last thing around the file, we're looking at dash set. This is an option we provide where we specify the that we want to find to run sound. So this again is going to find all files, all directories, files, and on each one it is going to files. So the find command helps us find files, right, based off of their file name or different attributes, but it's not searching in the files. grep will search inside of files. So the simplest way to use it is to run grep and then tell it some string or some piece of text or something that we're trying to find, and then a file to search inside of. So let me show you an example here. Let's clear this screen, all this craziness. I have this Song of Myself file. Here I open it in less. There's a lot of stuff in here. And I want to find every time this file, I don't know, mentions green in it. So I can do grep green songofmyself.txt. And it prints out to me the matches, and it highlights them in different color, of every time in this file the word green showed up. So we've got green leaves, green and violet, dusky green, pale green eggs, quintillions green. There we go. We can also ask grep to give us the line numbers with the -n option. So we'll add that in right there, -n. And now I'm getting the line numbers. So 32 is the first one, all the way to line 1026. I can also ask for some context if I use uppercase C, and then I provide an argument at the number of lines I want. In this case, 2. That will give me 2 lines before and 2 lines after each match. So let's try that. C, and then 2. And here we go. So this is one match. This is actually the last match on this line. We have 2 lines before and 2 lines after. Here's another match. Right, we have 2 lines after, 2 lines before. Another option we can pass to grep is -r, which is for recursive, and this is a bit different. This will actually tell grep, I do grep -r, and then provide some pattern like chicken. It's going to tell it to search recursively, in my case right now, in the current directory and all nested subdirectories. So instead of just looking inside of one file, like hello.txt, which doesn't exist, now I can look inside of all files, at least if I tell it a starting point, and the default is just dot. Okay, so what we see here is a bunch of matches, one from gg.txt, or a couple from sorted everything, feedstore.txt, website.html, greatgatsby.txt. So these are all files that were nested somewhere in my desktop. They all contain chicken. Now, it is important to note that it is case sensitive, so if I did, uppercase C, no matches, but I can make it case insensitive with -i, and now I get my matches again. Now, what makes grep really powerful is that it can work with regular expressions, which I'm not going to go over right now. If you know about regular expressions, you know the syntax, you can provide regex patterns to grep to search against. So you can find all matches of an email pattern or a phone number pattern, that sort of thing. Okay, well, I changed my mind. I'm going to show a quick example. I'm not going to explain any of it because regular expressions is its own crazy topic. But what I'm doing here is using a pattern, this is a regex, that will match email addresses. So I'm searching recursively across, in my case, the home directory until for any matches to this email pattern. All right, so I didn't type this out myself, just to be clear. I found an email regex, and I'm going to run it, and you'll see a bunch of different emails that have been matched. Bing at search.mozilla.org, toolkit.mozilla.org, toolkit at Mozilla again, Firefox. These are all coming from some documentation, it looks like, from Firefox. Here's some other ones. Anyway, the point is, we can match these patterns across in a file or across our entire machine, and there are tons of powerful regular expressions that you can write, but we're not going to talk about how that works. It's a whole separate topic. Anyway, that's a quick intro to grep. Next up, DU, disk utility. I think that's what it stands for. I guess I should verify. That would be the logical thing it stands for. Well, disk usage. No, I'm totally wrong. I'm pretty sure it's disk usage. Anyway, what we can do with DU is find the sizes of files and directories on our machine. So if I just run DU in my current directory, wherever I am, it's going to give me an output of all the other directories in here and their sizes. So you can see, if I just pick one of these, let's find some This tar demo folder is 32 kilobytes. This wildlife folder is 16. This cleanup directory is 156 kilobytes, and so on. And then down at the very bottom, I can see my actual current folder right here is dots is 36 megabytes. I can provide a folder to look inside of instead of just my current directory. I could say I want to know the Pokemon exercise folder. What's its size? And it's, let's see, 24. Okay. We can tell it to give us a different format, megabytes or gigabytes, using -G for gigs, -M for megabytes. So let's do do everything here, -M for megabytes. It's all just 1, maybe 2. If I do it on my Mac here, we may get some more stuff. Not a whole lot, but some of this stuff, here's something 410 megabytes. Here's something that's 25. Now, you may notice it's not actually giving me the unit, it's just 1 or 0 or 10. If I use -H, which is for human readable, it now is giving me a human readable size, so 4K, 24K, but then also for some of these larger things, we get, gigs, 5.7 gigs. So this is what I use most of the time if I actually need to read something as a human, -H. Now, here's kind of a nifty thing we can do. If I want to find the largest directories on my desktop here, I can do du-h for human readable. Okay, and I can pipe that to the sort command. Now, we're almost there. It is sorting, but the way that it's sorting is not exactly correct. If you notice here, it's doing a sort, once again, based off of the digits. So it's saying, 9.2 M megabytes is somehow smaller than 900 kilobytes. So it's putting all the nines together. That's a start, but it's not actually sorting them. So sort actually gives us an option. If I go to command sort, it gives us an option -H. Oh, where'd it go? I lost it. Here it is. Human numeric sorts. So it sorts by numerical value, but it takes into account prefixes or suffixes like K or M or G. So it's for human readable numbers. So let's run this again. We are going to get a human readable format from DU of all the files on my desktop, sort them with -H to get a human readable sort instead of the default sort. And now we go to the top, get our smallest files, the kilobytes, and down at the bottom we get our largest files. And if I wanted to find the top 10 largest files, for example, I get that, pipe that to tail. That would be one option. And there we go. I'm getting the 10 in this case because that's default for tail, largest. Or I could reverse with -R and instead get the head, which will be the same thing, right? I'm now getting the sort is in reverse order and I'm taking the first 10 instead of the last 10. Anyway, that's an intro to the du command. The next command we'll see, nice and quick one, is df, not to be confused with du. The du command showed us file sizes and folder sizes, whereas the df command will tell us information about the mounted file systems, how much space they take up and how much free space they have left. So I'll just show you very quickly here. If I run df with no arguments or options, I'm going to see output here. Yours will look different. The file system, each individual file system, and then the amount of size that it has been allocated, how much it uses, how much is available. Now this by default on Ubuntu is the 1 kilobyte block, so it's not so easy to read. If I switch over and use the -H option for human readable, now we get megabytes, kilobytes, gigs, and that sort of thing. Okay, so we can see things like, here is this file system, udev, here's where it's mounted, here's how large, how much space it's been allocated and how much it's using. I'll show you this on my Mac as well. So let's do that now. I have to zoom out quite a bit just so that you can see the columns. But what we'll see here is that some file system has been allocated up to 3.6. This is actually tebabytes, not terabytes. It's, let's see, it's a 1.1 times, so 10% larger than a terabyte. And it really doesn't matter. The thing is, I know this is a 4 terabyte computer, the drive here, so 3.6 gigabytes makes sense. Anyway, that's how much space it's been allocated, but it's only using, this file system at least, is only using 10 gigs. Or, here's another one. This is my /dev/disk 1s2 blah 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 blah. And here's where it's mounted. It's also has up to 3.6 terabytes to use, but actually it's used 2.2 terabytes out of that. Anyway, you may not really need to use this command, but I'm just being comprehensive here. One thing that can be nice though is if we pass a file folder as an argument to df, it will tell us more information about the file system that particular file or folder lives on. So if I wanted to know, where's my desktop and how much space is that file system taking up, I can do let me just clear first. I can do df-h for human readable, and then desktop. And you can see this is the file system. This is the capacity of that file system, how much is available, and so on. So that's all there is to df. And remember, du tells us about the actual sizes of individual files or directories. df tells us about, I don't know if it's disk free or disk file system, or what the F stands for. I was trying to look at the man page and figure it out. But think of it as disk free, sure. Next up, the history command. Now this one can be very useful, especially if you have some long commands you ran, I don't know, 20 or 500 commands ago, and you want to run it, you don't have to type it yourself again, or you don't know what it was. That is what the history command helps us with. So on its own, if we just run history, let's do it here on a Linux machine. So I'm going to run history here. I'm going to get a bunch of lines. As you can see, there's a number next to each, and then a command that I ran. So we can see history of all the commands that I've run. So history was the most recent command. Before that, I have man, df, and then du-m. I had clear. I had du, all these different commands. And let's say this is the command I want to rerun. This is the query that will search for regular expressions. It searches for emails using an email regular expression across my entire machine. I don't want to have to type this myself. One option, I guess, it's just to copy and paste that, definitely. But there's also something called history expansion, where if I have that number, and your numbers are going to be different, but if I have that number, I can take it and simply run exclamation points and then that number, 2064. And now it's running that command. Again, it's finding all these matching emails across my machine. So just one more example, that would be to rerun history. And if you prefer, you can actually pipe this to less. So that command less opens up a program where we can scroll a bit easier. We can page through commands one at a time. I can find some command like, this one here, that finds things that start with the letter E or F. So for 2040, I can exit less and just run exclamation point 2040, and now it finds me all the files and directories that have an E or an F, uppercase, as their first letter. Another thing you can do is actually combine grep with history. If you're trying to find some command you ran a long time ago, as you probably just saw, there's tons of commands here, and somewhere in this massive list, a history list, there was a command I ran, and I know that it included the word cookie, but I'm not sure where it is, and I want to rerun that. Well, I can run history and then pipe that to grep. Remember, pipe, that pipe character allows us to take the output of one command and pass it as input to another. So then I can search for cookie. And there's quite a few, actually, surprisingly, where there are commands. So we're just searching through the text from history using grep. I found a match, 5 or 6, 7 different matches. And if I want to run one of these, I can take that number and exclamation point, that number. So 1686, it's just going to make me a bunch of files. So you're going to want to do that. Not really, but I've already committed. Okay, so you can see it made me those files. I think it was cake and cookie, and there's cookie. Cake is up here somewhere. Anyway, that can be quite useful if you know somewhere in this massive history there was some command and it included some pattern or some word, and that's all you remember. Well, you can use grep to search for it. The next command we'll cover is ps. So ps is a command that helps us inspect or view the processes running on our computer. So if we take a look at man ps, process status is what it stands for. Didn't actually know that. I just always thought of process in my head. Anyway, it's going to display information about currently running processes. And by default, if we just run ps, I'm on my Mac in this example, with no other options or arguments, it shows me a list of all the processes started by me, the current user. So what we see here, we've got, well, first of all, the process ID, we've got the time, we've got the actual command. You can see I've got a bunch of bash shells, and then really the only somewhat interesting thing, I guess, would be this Python process I have. I have a Python server in a different tab that I've started. But just to show an example, I'm going to start a Node server in this tab. I've got this app.js. I'm going to run it with Node. Here's my server. It's running. Started a new process. Now if I run ps again, we see somewhere, there we are, that process right there. Okay, so that is a process I started, and we can see it right in this list. It has an ID, and in a moment we'll also learn how we can kill a process where that ID can come in handy. But there's more to this command. We can also view a list of processes initiated by anyone on our machine, basically all the processes, not just the ones that are user initiated by me. So all processes. To do that, psax. So this is a pretty common one, psax. We're going to see a lot more going on here. So we still have that Node server I started up, got our bash instances, and then a whole bunch of system stuff. Look at all these processes. Now you will see they get cut off here, so they don't wrap over to the next line. I can't scroll, it just gets cut off. So there's a way around that.